What's up, guys? Today we're going to be finishing lesson 10.1, which is about properties of tangents. I'm going to write down the vocabulary, or I'm going to paste a picture of it. There's the vocabulary that we did the other day. I'm not going to go over it, so if you need it, copy it down or whatever. So I'm going to go into the some problems we need to work on. So let's start with a question and I ask, how many common tangents do both circles have? Well, remember, a tangent only crosses it once. So we had a line right here. There you go. That's one line. It crossed the circle right here and right there, and then another one on this side. Yeah, I kind of went in, but you get the point there. We touch the circle once and once over here. We can't go in here. We can't go straight down. If we come on top, we're not going to touch the bottom one. So there's how many common tangents for both circles. So this one only have two. We have two common tangents. Let's try one more. On this one, they're a little bit different. This one, the circles they intersect right there. They don't overlap. So here we have a line that would be coming here and there. So we cross right here and right there. So it touches both circles one time only a piece. That's okay. The same for this side. Right there and right there. And we can't go over here because it's only going to touch the bottom circle. We can't come up here because it's only going to touch the top circle. But we can come in the middle. And since they're touching right here, it's going to touch both of them at the same time. So we have 1, 2, 3 tangents. An example of 0 tangents would be something like a donut. So that'd be one circle. Here's another circle. So we try to come in here, well, we touch the circle more than once. That doesn't work. We try to come up here, we only touch it one time here. We come right here at the bottom, we only touch it one time at the bottom. We try to go up and down, we touch it more than once. It doesn't work. So those two circles, like a donut, have 0 tangents. Just FYI. Alright, so let's actually start to work on some problems now that involve mathematics with numbers and x's, algebra. Well, they're going to call it Theorem 1. Theorem 1. It's going to be over tangents and the radius, the relationship between them. It says, in a plane, a line is tangent to a circle if and only if a line is perpendicular to the radius of the circle at its endpoint on the circle. What? It's tangent if and only if the line is perpendicular, that's the key word, perpendicular to the radius. So this line right here, the only way we can call it a tangent is if it is perpendicular 90 degrees to the radius. So in this question, QP is the radius and PM has to be 90 degrees perpendicular, upside down T, perpendicular to QP. That's the only way it works for PM to be a tangent. So a question would be like this. So right here, CB is the radius CV is the radius. CA is just a line coming out. And we're trying to figure out BA. Is BA a tangent? And if it is, how much is X? Well, it's in a triangle. I mean, it's in a circle. It makes a right triangle. Even though it's in a circle, the same work still applies. We have a right triangle. How do you solve right triangles? Well, using trigonometry, SOHCAHTOA, or Pythagorean theorem. A squared plus B squared equals C squared. And here's my right triangle. Here's my 90. Across the 90, that is always the C. You don't have a choice. This is the hypotenuse. This is always the hypotenuse. So this is 80 squared. You cannot change the C because C is always across the 90. Now it doesn't matter where we're going to put the A or B. Like you want to call 48A or 48B, doesn't matter. So I'm just going to call 48A squared plus, that'll be my A, we'll call that B, and that'll be my C, plus X squared. So we do the work, figure out how much 48 squared is, which is 2004, plus X squared equals 80 squared, which is 6400. Subtract the 2304. And that leaves us with X squared equals 4096. How to get rid of X squared? Well, you take the square root. And the square root of 4096 is 64. So X equals 64. We're going to do at least 2 to 3 problems like this. Then they like to get a little tricky, which I like, in a question like this, which is the same work. It's still going to be A squared plus B squared equals C squared, except it's a little more tricky. Something like this. Now, let's take a look at this triangle, see what's going on. Little triangle and circle. BC, this is the radius. So from C to here, some unknown point, this is also the radius. They're the same length, of course they are. But AB is a tangent because it is a line that's going to touch the circle only one time. AC is the other line coming in and out of the circle, and it makes a right triangle. So this, I'm telling you, this is the radius. BC is the radius. We can do Pythagorean theorem, which would be A squared plus B squared equals C squared. Now, remember what I told you. Here is the right angle. You cannot change it. But across it is always the C. So from here to here, that's C. All of that is C. And then it doesn't matter what you call A and B. So I'll call this one my A, call this one my B. So we come over here. How much is the A? A is X squared. Plus my B, B is 63 squared. My C is all of this. It's 49 plus X. Do you know how much X is? No. So I'm going to say my C is X plus 49, and all that is squared, because all of this is my C. Now this right here is algebra 1. I'm just going to do it right here. X plus 49 squared. That means there's two of them. X plus 49, another X plus 49. And we do FOIL method. But we can want to finish this real quick because it bothers me. X squared plus, and then 63 squared is 3,969, and I'm looking for some stuff over here. So we do FOIL. X times x, x squared. Try to do a different color so you can distinguish. So x times x, x squared. And then x times 49, that is 49x. Then we have to get 49 times x, which is another 49x. And then 49 times 49. Which is 2,401. We can combine these. Bring down the x squared. 49 plus 49, because they both have x's, is 98x. And then bring down the 2,401. So this equals x squared plus 98 plus 2,401. Now we're talking. This is a math question. That's what I'm talking about. Now, they both have x squared. You see, there's an x squared right here, and an x squared right here. If you subtract x squared, they cancel. So we're left with 3969 equals, oh, forgot the x, people. Forgot the x there. Equals 98x plus 2,401. I already have x here all by itself. So subtract this number. We have 98x is equal to 1568. Then we divide by 98. And that gives us x is equal to 16. I know there was a lot of steps, a lot of places you can go wrong, especially right here. But this is pretty much college work right here. Or like college work, which is very nice. You can get used to it. I would replay this part of the video slowly, because if you come to class and just copy down these notes, you're going to be screwed. You're not going to pay attention, which is not really my fault. That's why these videos are here for you to rewind and pause. So anyways, on to the next question, because I understand this. And here's the next theorem about tangents. Tangent segments from common external points are congruent. What? See, R and T, they are on the outside. That's what they call external points. That means that if they meet at the same point, RS equals ST. They're congruent. So if this is 10, that one's 10. If this is 10x, that's 10x. Over and over, same thing. So let's do a question real quick over that. Alright, we got two tangents. They both meet at J, so it means they are equal. That means that 3x, squared minus 10 is equal to 17. Add 10. 3x squared is equal to 27. Divide by 3. And we get x squared equals 9. How do you get rid of x squared? You take the square root. Square root of 9 is 3. X equals 3. This type of question was easy smeezy. I bet you thought it was going to be hard because of the x squared, but no, it was easy. So as long as you have two tangents, two lines on the outside that meet at one point, they are equal, congruent, which makes life simple. Alright guys, see you in class later.